Assalamu alaikum and hello everyone. Today we start with a new topic, which is convolution. If you remember in previous class, I explained the system presentation. So in the question, an equation will be given, and we need to find the h of n, which represent the device equation or the system equation. And by that h of n that we found, we need to find y of n, the output. And you remember there is a fixed equation for y of n, which is y of n equal h of 0 multiply x of n. Let me write it. So this is the fixed equation, which I explained it last lecture. Y of n equal h of 0 multiply x of n plus h of 1 multiply x of n minus 1 plus h of 2 multiply x of n minus 2 plus h of 3 multiply by x of n minus 3 and so on. So we apply this equation to the previous two examples for the previous lecture. By the way, this output y of n, it's not perfect equation. We use it to represent a specific system or a specific cases. But actually, finding the y of n is done by equation or method. We call it convolution, which I will explain it in this lecture. So the convolution is the process of finding the output y of n by x of n, the input, and the h of n, which is the system equation, or let's say the device signal, or the unit impulse response, as we call it in last lecture. So if we have a question in final exam related to system representation using its impulse response, in this case, we will use that way, which is I explained it previous class, where y of n equal h of 0 multiply x of n plus h of 1 multiply x of n minus 1 and so on. Okay, but if the given question stated that we need to find the y of n using the convolution, then we will use the convolution method, which is the perfect way to find the output by the input x of n and h of n, which is a unit impulse response, or we can say the system equation or the device equation. Okay, so as you see here, linear convolution. Okay, why linear convolution? Because there are two types of convolution, linear and circular convolution. But generally, 95% of the convolution used is linear convolution, not circular convolution, because circular convolution, it's old way. So the linear convolution here, a system that is both linear and shift invariant, time invariant, is referred to as a linear shift invariant, LSI system. So to be perfect system should be linear, should be a time invariant, causal, additivity, and homogeneity. Okay, homogeneity, in order to be an integrated system in terms of signal and device. Should all these properties exist in this system. Okay, so to finding y of n will be done by x of n and unit impulse h of n. Why we call the h of n as unit impulse response? Because the signal that I'm using it in the device is unit impulse response. As you see here, this is the main equation, y of n equal x of n multiply h of n. Okay, convolution properties. There are some properties of the convolution. One of the important properties is commutative property. What is the commutative property? It stated that the order in which two sequences are convolved is not important. Mathematically, the commutative property is x of n multiply h of n equal h of n multiply x of n. Okay, that's mean originally the input x of n entering the system or the device, multiply it by the device signal or the signal of system, and we get y of n. So the signal x of n entering the device, multiply it by h of n, the device signal, and the output become y of n. So the commutative property means we can exchange them as you see here. So the entering signal can be h of n. So the h of n can enter the device, which has a signal x of n, multiply them and get y of n. So the input can be h of n, and the device signal or the equation can be x of n. We just exchange them. Okay, this is the first property. Okay, the second property is associative property, as you see here. So associative property means we have two systems here, as you see. We have two systems. Each system has a signal based on this figure. So we have two devices. The first device, the receiver, its equation or its signal h1 of n. The second signal of the second device is h2 of n. So the entering signal x of n, by the way, in condition that these devices are connected in series. Okay, so when x of n enter the system, first it will be multiplied by h1 of n. Then we also multiply it by h2 of n. Okay, as you see here. So instead of doing two multiplications, we can combine the two signals in one system. So here we have a system got one operation or one signal, which is h1 of n multiply h2 of n. So when x of n enter the system, the operation will be x of n multiply h1 of n multiply h2 of n. So here we have one system with one operation or one signal. So the third property is a distributive property. Okay, based on this figure, we have also two systems, h1 of n and h2 of n. These two devices are connected in parallel. So in the previous property, those devices connected in series. Here, the devices are connected in parallel. So in parallel means in groups, as you see here. When the x of n enter the system, there is a possibility to distribute it, the x of n. So look to this equation. Instead of x of n multiply h1 of n plus h2 of n, we can distribute it like that. X of n multiply h of n, h1 of n plus x of n multiply h2 of n. So as you see here in figure, y1 of n equal the first x of n, multiply it by h1 of n, then the second operation plus the second operation x of n multiply h2 of n. So we distribute it. So these were the three types of convolution properties. Just to understand how is the equation or the signal can be distributed or combined or exchanged. Okay, now let's talk about type of convolution. There are three types of convolution, or three ways to find the convolution. Okay, equations method, graphical method, and alternative method. The most commonly used method is graphical method. So the most commonly used method to find the output y of n using convolution is graphical method. Okay, so this is these the steps which we need to use to find the convolution using the graphical method. Okay, plotting, flooding, shifting, multiplication, and summation. Let me give you an example using auto draw. Yeah, I will explain these steps in more clear way. Okay, look to this question. Find y of n by graphical convolution where x of n equal -2, 3, 1, and h of n where -1, -2, and 5. Okay, so before we start finding the solution here, what's these three numbers here? X of n equal -2, 3, and 1. These numbers means signals. So the x of n provide three signals. So -2 actually it's pulse. We have agreed that we will deal with the system in general by representation of the signal, which is unit impulse. And we know the unit impulse has only one pulse. The general of the unit impulse is only one pulse. Only at 0, the value is 1. The amplitude is 1. And we learn that we can do shifting on it to the right side or to the left side, or multiply it, I mean scaling, that the amplitude can be increased or decreased. So now we have three signals, -2, 3, and 1. So definitely we will need h of n to multiply them to find the output, y of n. Okay, as you see in h of n, also we have three signals. By the way, student, it's not necessary that the number of signals be equal in x of n and h of n. Okay, maybe x of n got more or less signals compared with h of n. Okay, but in this question, they got equal number of signals. But it's not necessary to be equal. Okay, and mostly the h of n got more signals because x of n it's received signal, while h of n we can manipulate it to the left side or to the right side. Okay. Okay. What does it mean, this arrow? As I explained in the first lecture, beginning of semester, this is a starting point. This is zero location. So to do this kind of, it's graphical. This kind is graphical means we need to draw these signals. How we can draw these signals if we don't have starting point? So to draw it, we need the zero location. So this arrow shows us that 3 is located at 0. Okay. On the right side, we have the positive signals, means 1 located at 1. And in the left side of the arrow, we have the negative part. So -2 is located at -1. And if we have more numbers after 1, for example, we have 4 and 9, okay? After 1, we have 4 and 9. 1 located at 1, 4 located at 2, and 9 located at 3, and so on. And same things for the negative part. Okay, so this is a graphical method. The solution here is graphically. That's mean we need to draw the x of n. Let's draw the x of n. X of n as I explained just now. The arrow here means 0 location. So at 0, we have signal with value 3. Okay. So on the right side of the arrow, it's positive part. So 1 located at 1. 1 will located at 1. This is 3 and this is 1. Okay. And on the left side of the arrow, we have negative part. So negative 2 will locate it at negative 1. So here negative 1. The value of this signal is negative 2. Okay. This is for x of n. Let's draw h of n. H of n. Okay, negative 1, negative 2, and 5. Negative 2 located at 0. So 0. The value is negative 2. Okay. On the right side will be positive, will be located at 1. So 5 located at 1. This is 1. The amplitude is 5. The left arrow is negative 1. Negative 1 is located at negative 1. Okay, this is x of n and h of n. So this number is the amplitude of each signal. So first step, we draw x of n. Second step, we draw h of n. And the third step, we need to flip the h of n. We need to flip it. Okay, h of n become h of negative n. Okay, you remember in the beginning of semester, I explained how we do reversal or flipping. Okay, by the way, there are two types of flipping. The first, it can be flipped around the 0 axis. Okay, means the signal at 1, it become negative 1, and the signal at negative 1 become 1. So if we draw it, it will be like this. Zero, negative 2. We just exchange this one. Okay, this is, we call it flipping around the 0 axis. So the 1 become at negative 1 with value 5, and at negative 1 become at 1. Become at 1 with value negative 1. Okay, like this. This we call it flipping around the 0 axis. The second method that we need to follow it now, by the way, the both cases are correct, okay? But let's follow the second way as I explained it earlier in the beginning of semester, which is we need to reverse it like mirror. We reverse it like mirror. So simply flip the signal to the other side like mirror, but don't forget to keep the first pulse at the same place or at the same time, which is -1. Don't change it. We just reverse the other pulses to the other side like mirror. Okay, so here the graph become like this. This is -1, -n. It become we keep the first pulse at -1 with value -1. Okay, and we change these two pulses to the other side. -2, value -2, which is at 0, become to this side. So -1, after -1, -2, become to -2, come at -2. Okay, the value so -2. And 5 become to the -3. Okay, 5 become to at -3. Okay, so first step we find we draw x of n, then h of n, then we find the h of a -n. Okay, so now we can start with the multiplication. Let's say first step, when n equal 0, y of n equal x of n multiply h of. So all the previous steps were only drawing. That's why we now start with multiplication. So we draw x of n, then we draw h of n, then we flip h of n become h of -n. So by the way, student, when we start the multiply operation, okay, we know the y of n equal x of n multiply h of n. Okay, so here the multiplication process will be between x of n and h negative n, h of -n, not h of n. Okay, that's why means we will ignore the h of n. That's why we flipped the h of n to become h of -n, because we need to multiply x of n with h of -n. Okay, so and when we flip it, we start with shifting. But from the beginning here, when n equal 0, okay, the first step here, we start with n equal 0, y of n equal x of n multiply h of -n. Okay, we multiply x of n by h of -n without shifting, without shifting. So means with its position, no shifting here, no any change. The shifting will start when we're going to n equal 1, n equal 2, n equal 3, and so on. Okay. Okay, so in this case, since n equal 0 means y of n, sorry, y of 0. Okay, y 0. So we are at n equal 0. When n equals 0 means y of 0. So here we need to multiply x of n by h of negative n. This signal remain at same position. Okay. By the way, generally, the shifting will have happened later when n equal 1 or n equal 2 and so on. The shifting will be only on h of negative n. Okay. The x of n will remain same. But now when we are at n, when n equal 0, no need to do any shifting here. Okay, the shifting, as I said, will start next step when n equal 1. So here we need to multiply x of n by h of negative n. To multiply them, we need to find the shared signal. Okay, we need to find the similar location. How to find the similar location? Look here. We have at 1, we have signal at 1. Okay, in x of n, we have signal at 1. While in h of negative 1, we don't have a signal at 1. We have at negative 1, negative 2, and negative 3. Okay, and same things at 0, we have a signal in x of 1 graph. At 0, we have a signal, while in h of negative n, there is no any signal at 0. Okay. At negative 1, we have a signal here. And here also at negative 1, we have a signal. Okay. So the shared location or the shared signal or similar location only at negative 1. Here the value is minus 2, and here the value is minus 1. So we multiply them. Here will be negative 2, which is come from here, negative 2, multiply multiply by negative 1, which comes from here. Will be equal to. Okay, students. So here we multiply only the shared signals or similar location. If you also look to the h of negative n graph here, we have a signal at negative 2. Okay, the value negative 2. While at negative, there is no negative 2. Here, there is no any signal at negative 2 in x of n graph. Okay. Also here we have negative 3. At negative 3 we have value which is 5. But in the x of n there is no negative 3. There is no signal at negative 3. Okay. Only at negative 1. Only at negative 1. Here we have a signal in both graphs. So the value is negative 2 here, and the value here is negative 1. We multiply them and we got 2. Okay, because this value got same location at negative 1. Okay, others cannot. We cannot multiply them because like we multiply 1, this one, okay, by 0, it will be 0. Like we multiply 3 by 0, it will be equal 0. There is no signal. Same cases in this graph. Like we multiply negative 2 by 0 will be 0. Like we multiply 5 by 0, the result will be 0. Okay, so only at the similar location we multiply them, we multiply their values. Okay, negative 2 multiply by negative 1, we get 2. Okay, so here the next step, when n equal 1. Okay, what does it mean n equal 1? Means the h of negative n will be shifted to the right side by 1, to the negative part. So h of n become, sorry, h of negative n become h of negative n minus 1. Okay, you remember, if the shifting to the positive part, we write n negative n minus 1. Okay, if the right side to the positive part. Okay, and if the shifting to the negative part, we write n plus 1. So here we need to do the shifting to the right side, to the positive side. We write h of negative n minus 1. Okay, so as we learned before, each signal or each pulse will move to the right side by 1. So means negative 3 will become at negative 2, negative 2 will become at negative 1, and negative 1 will become at 0. Okay, that's the shifting to the right side. Let's draw the graph for h of negative n minus 1. It will be the first pulse will move to the right side by 1. So 5 value become at negative 2. Then this will be negative 2 become to negative 1. The value minus 2. And this signal at negative 1, it will become at 0. At 0. Okay. So, by the way, the signal's value do not change. The signal value, the amplitude, do not change, like 5, negative 2, and negative 1. It doesn't change. It's still same value. Only the places are changing. Okay. Okay. So here, after shifting, what the next step? The next step is we need to multiply the h of negative n minus 1 by x of n. Okay, we need to multiply them. So it will become here y of 1 equal x of n multiplied by h of negative n minus 1. Okay. Now to multiply them, we need to find the shared signal or the similar location. Okay. Let's take a look here at x of n. We have a signal at 1. Okay. As you see here, we have signal at 1. While here, there is no signal at 1. Okay. Look to the 0. At 0, we have a signal. And here also at 0, we have a signal. Here at minus 1, also we have a signal. And the h of negative n minus 1 also at minus 1, we have a signal. Okay. Yeah. And here at minus 2, here we have a signal at minus 2, but there is no a signal at minus 2. So here we have only two shared signal or two similar location, which is at 0 and at minus 1. At 0 and at minus 1. So here we multiply these signals. So 3 multiply it by negative 1 and minus minus 2 at negative 1 minus 2 multiply it by minus 2. Okay, so here will become y 1 equal negative 2 multiply by minus 2. Okay, plus, so here minus 2 multiply by minus 2, this, and at 0, 3 multiply minus 1, 3 multiply by this one. Okay, so here minus 4 minus 3 become 1. Sorry, 4. Here 4 minus 3 become 1. So the result here is 1 when n equal 1. Okay, so now the next step. Okay. When n equal 2. Okay. Means the third step when n equal to. Here means h of negative n, h of negative n will be shifted to the right side by 2. Okay, to the negative part by 2 and become h of n, h of negative n minus 2. We shift it to the right side by 2. Okay, so here we have two options. You can refer to the original h of negative n and we do shifting by 2, or refer to the last one, to the last signal, which has been already shifted by 1, and we shift this, this last signal, we shift it by 1. Okay, we do shifting to the right side by 1. So we have two options here. We do shifting by 2 to the original h of negative n, or we refer to the last figure which already shifted by 1 and we do one more shifting by 1. Okay, I refer the second option. Just we follow the last figure and do shifting, one more shifting by 1 to the last figure. Okay, so this will become negative 2 become negative 1. Okay, negative 1 becomes 0. And 0 become 1. Okay, as I said, we don't need to change the value, the amplitude. We change only the places. So this is our h of negative n minus 2. So now we need to find y of 2. Okay. Y of 2, we need to multiply x of n by h of negative n minus 2. Okay, so x of n multiply by h negative n minus 2. Okay, so to multiply them, we need to find the shared signal. We need to find the shared signal. So the shared signal, or the similar location between x of n and h of negative n minus 2. As you see here, we have signals at 1, 0, and minus 1. Let's take a look to the x of n at 1, 0, minus 2. So that's mean we have signals shared with same places at all. Here we have at 1, and here we have at 1. Here we have at 0, there also we have at 0. And here we have signal at negative 1, and there also we have signal at negative 1. Okay, so we multiply them. We multiply all the signals. Here all the signals shared with the same places. So we multiply them and we find the result. Y of 2 equal. Okay, we start with minus 1. Okay, negative 2, and here minus 1, 5. So negative 2 multiply by 5 plus, at 0 we have 3, at 0 we have minus 2. So 3 multiply by minus 2 plus, at 1 we have 1, and here at 1 we have negative 1. So 1 multiply negative 1. Negative 10. So will be negative 17. Negative 10 plus negative 6 minus 16 plus minus 1 minus 17. So the result minus 17 when n equal 2. Okay, so now we're going to next step. when n equal 3. Equal 3. Okay. So we will do shifting by 3 to the right side for h of negative n, the original one, or we do shifting by 1 to the right side for the previous or the last signal that will already shifted by 2. This one we do only shifting by 1 to the last figure. Okay, so I prefer this one, much easier. Will be here h of negative n minus 3, and we shifted by 1 to the right side. Negative 1 become 0. 0 become 1. And 1 become 2. Okay, so this is our h of negative n minus 3. Now we need to find y of 3. To find y of 3, we need to multiply x of n multiply it by h of negative n minus 3. To multiply them, what we need to do, we need to find the shared signal or the similar location between x of n and h of minus n minus 3. Okay. So the shared location here here we have at 0 and x of n also we have signal at 0. Okay. Then at 1 we have here at 1 we go to x of n, we also have at 1. Okay, so only at 0 and 1, because here negative 1 and here there is no negative 1. Okay, and here also we have at 2, there is no 2. So only at 0 and 1 we have values. We will multiply them. 3 multiply by 5 and 1 multiply by 1 at 1 multiply by negative 2. Okay, so here y of 3 multiply by 5 plus 1 multiply by 1 by minus 2. So 15 minus 2 equal 13. This is when n equal 3. Now the next We continue. Next step, when n equal 4. Okay. When n equal 4, we continue. As I said, we do shifting by 4 to the original h of negative n, or we do shifting by 1 only to the last one, which already shifted by 3. So n h of negative n minus 4, we shifted this signal only by 1. So at 0 become at 1. At 1 become at 2. And at 2 become at 3. Okay. So now we need to find y of 4. To find it, we need to multiply x of n by h of negative n minus 4. To multiply them, we need to find the shared location. The shared signal or same. Okay, so here we have 1, 2, and 3. 1, 2, and 3. Here there's no 2 and 3. We have only 1. So only at 1 we have same location. The value is 1. At 1 the value is 1, and here at 1 the value is 5. Okay, so we multiply them. Y of 4 equal 1 multiplied by 5 equal 5. Okay, so here we can stop. No need to find n when n equal 5. Why? Maybe someone will ask when we have to stop. Okay, we will stop when the shared signals or the similar locations become only 1. Like in this case, the shared signal only at 1. Here at 2 and 3, there is no 2 and 3 in x of n figures. We have only at 1. So when the shared when the similar location or shared signal become 1, in this case we will stop. Okay, so because even if we do shifting here, look to this figure, even if we do shifting, one more shifting, 1 become 2, 2 become 3, 3 become 4. So means 2, 3, 4, 2, 3, 4. We go back to the x of n. There is 2, 3, 4. Here, minus 1, 0, and 1. There is no 2, there is no 3, and there is no 4. So nothing to multiply, nothing to find here. So in this case, we will stop. Okay, there is another way also to know when we can stop. It actually based on the number of results. Of number, how many y we got, how many number we got. Okay, let's count the result here. The first result, y of 4. Okay, this is the first one, y of 4. Then the second number 2, y of 3. So here result 1, 2, okay? Y of 4, Y of 3, Y of 2, 3 result. Y of 1, 4 result. And Y of 0, 5 result. We got 5 numbers by shifting and multiplication, okay? 5 numbers. Now, let's refer to the given question here. In the given question, we have x of n. Got how many numbers? 3 numbers. And h of n. Also, how many numbers? Also got 3 numbers. So total 6. 6 minus 1 equal 5. After finding 5 result, we will stop. Okay? So means the number of results or the number of y of n will be equal to the sum of the numbers between x of n, okay, and h of n minus 1. So the total here, 3 plus 3 is 6, minus 1 become 5. It's fixed equation. n1 plus n2 minus 1. So 3 plus 3 equals 6. 6 minus 1 equal 5. Means we need to find 5 values of y, as you see here. Okay? We need to find 5 values. This is the first value of y. This is the second, when y of 1. This is the third. Okay, number 3, number 4, and number 5. Okay, this is fixed equation. X of n, the number of x of n, 3. The number or the signals of h of n is 3. 3 plus 3 equal 6. And 6 minus 1 equal 5. Okay. So that means we need to find 5 values of y. Now let collect each result. Okay. Let collect each result of y of n. Y of 0. Y of 0 is 2. So 2, 1, 7, negative 17, 13, and 5. So here y of n 2, 1, negative 17, 1, negative 17, 13, and 5. And don't forget to put the arrow under 2. This will be our first or starting point, okay? Under the first result, we got it when n equals 0. So this will be, if we draw it by graphical way, okay, this will be located at 0, this is at 1, this is at 2, this is at 3, because on the right side will be on the positive part. Okay, and this is at 4. If we have more number, would be 5, 6, and so on. Maybe someone will ask, why here we did the shifting to the right side only, to the positive part? Why not to the left side, the negative part? Okay, so because let's go back to refer to the original signal here. H of negative n, okay? If we do shifting to the left side, to the negative part, there will be no shared signal. Look here, minus 3 will become minus 4. Minus 2 will become minus 3. Minus 1 will become minus 2. So total minus 2, minus 3, and minus 4. If you compare with x of n, there are minus 1, 0, and 1. So no any shared signal. So here we done the shifting and we found the 5 values of y of n as requested without do shifting to the left side, only to the right side. But generally, the shifting in convolution, it to the left and to the right side, not only to the right side. We just lucky here, we got the requested result just by right side shifting. Later, I will give one more example to show you how we can do shifting to the left side and to the right side. Okay? I hope everything is clear. That's it for today. Thank you and best regards.